So let's check now the solution for our first problem in our quiz. We have this beam here, as we can see, and this time it is different because he is giving us already the shear force diagram and he wants to obtain the original beam. So we are just going backward in the calculations. Let's start by checking the shear force diagram. We have this vertical force here, it's going 12, then again it's going down to 14, going up to value of 6, 12, 14. It will keep going downward till he reaches 4. Again we're going up to 4 and 4. So this is the shear force diagram that we have, and of course we have the distances as we can see here. And he wants from us to obtain the original beam. How does it look like? And from it we can calculate the bending moment diagram. Let's start as we always do, except this time we are going backward. We have our beam here. Let's start from the left side. We have here this shear force diagram. It is going downward with the value of 12 kilonewton. It is going downward, and from the left side, which means we have a vertical force of 12 kilonewton going downward here. So this is our first force here. Starting from here, the force will keep decreasing, as we can see, from 12 till it reaches 14. It is increasing in the negative sign, which means there are increase in the vertical forces here, but it is going gradually. And we know that the gradual increase in shear force, it means there are distributed forces here. So what is the value of the distributed forces? We have this area or this length, sorry, of 2 meters, and the decrease or the increase in the moment here, we have this length of 2 meters, and we have the increase in the shear force from 12 to 14. So it increased 2 kilonewton in 2 meters. So the rate of increasement of is 1 kilonewton per meter. So we have here 1 kilonewton per meter. And now the shear force went up from 14 in the negative sign to 6 in the positive sign, which means there is vertical force here of 20 kilonewton. 20 kilonewton will take it from 14 negative sign to 6 in the positive sign. So this must be our vertical reaction here of 20 kilonewton. We will keep going again from the 6. It will keep gradually going down till it reaches 4 in the negative sign. So from 6 in the positive sign till 4 in the negative sign, it means it decreased by 10 kilonewton in the distance of 10 meters. So this again rate of a change of 1 kilonewton per meter. So this means that this distributed forces is actually extended till the end here with the same value of 1 kilonewton per meter. And at this point it went up from -4 till +4. So this is increment of 8 kilonewton. So this is our second support of 8 kilonewton going upward. If we look here, it will keep going straight. So it means that there are no any other forces here in this 2 meters of the beam, and it went down again. So it means that the distributed forces stopped here, and we only have 4 kilonewton at the end, because it went, of course, from the 4 till the 0 in the end. So now this is how our beam looks like. We have this 12 kilonewton vertical, this 4 kilonewton vertical downward, this distributed forces of 1 kilonewton per meter, and 2 vertical supports of 20 kilonewton and 8 kilonewton going upward. And now it will be easy for us, like we learned, to draw the bending moment diagram for it. This is our beam. Let's start calculating the moment here. We have this 4 kilonewton multiplied by this distance of 4 meter, which means it's 16 kilonewton meter, and this moment it's going in this direction. It is causing tension at the upper side and compression at the lower side, so it means it is negative moment. So we have here this value of 16 kilonewton. Let's calculate from the other side. From here, if we calculate the moment here, let's look. We have this 12 kilonewton multiplied by 2, which means 24 kilonewton meter, and we have the resultant force for this distributed force in the middle here. This is 1 kilonewton per meter in 2 meters, which means concentrated force of 2 meter in the middle. So it is 2 meter multiplied by 1, which is the distance from the center. So it is 2 kilonewton meter plus 24 kilonewton meter. So we reach till 26 kilonewton meter. And again, it is causing tension upper side, compression lower side, so it is negative. We need to connect this point. From here, we have this only concentrated force, so we'll connect by straight line. But from here, when we start, we want to connect to here, we have distributed force here in the middle. So it means that it will not be a straight line, it will be parabola, like we learned it in our last video. So we will connect only with dotted line now. And between here and there, again, it is also distributed force. So this is another parabola, which means that here our actual moment will look like this. And this value, this small value, when we want to calculate it, it equals WL square over 8. W here equals 1 multiplied by L square, which is N square, 2 square, sorry, over 8, which will equals to 0.5 kilonewton meter. So this value here, it's 0.5 kilonewton meter. And if we want to calculate this point, this is the midpoint between the 26 and between the 0. So the value here is 13. We are going 0.5 below it for the parabola. So this value here is 12.5. Let's do the same in this side. We will calculate again. We will draw this curve for the parabola, and we want to calculate this distance. This distance equals to WL square over 8, which equals to 1 multiplied by 10 square over 8, which will equals to 12.5. So this means that this distance is 12.5. This point in the middle here, it is in the point in the middle between the 16 and the 26. So this means this point is 21, and we will go 12.5 from it, 12.5 from the 25, so we will reach the point of 8.5. And of course, this is all negative sign moment. So this is it for our first problem in our quiz. Thank you.